All right, so I'm looking at this one and I'm calling this special systems, but reality is this is really about classifying systems and reasonableness of systems. Our objective here is to classify systems of linear equations and determine the number of solutions. Your big question is, how can you determine the reasonableness of a solution for a system? How can you reason that the answer that is given or you got would fit the situation or make sense? Or does it sound reasonable that that's the right answer? So let's look at the different types of classifications. You have like three types of answers, and we've talked about this before very briefly. You have one solution, which is what you've been doing. When you find the answer, you have one solution. Keep in mind that that can be called a consistent independent system. If a system of equations can come up with one answer, an x and a y, that is considered a consistent independent. When it has many solutions, like infinite slope, one line over another, it's called a consistent dependent. When you do this by elimination, if everything canceled out, that's many solutions, consistent independent. I'm sorry, dependent. No solution, parallel lines, then that would be an inconsistent system. If you're doing elimination, the x and y cancel out, but not the answers. And you'll see what I mean by the examples in that in a second. Okay, so here's an example. I decided to do this one by graphing. Y equals 2x plus 1, y is equal to 1/2, parentheses 4x plus 2. If you graph this, you end up with, say, two lines that are one on top of the other. So if that's the case, this would be considered infinite solutions. But let's go further than that. Instead of calling it infinite solutions, let's say a consistent dependent system. Consistent means it has an answer. Dependent means, well, there's lots of answers. So there you go. Consistent dependent system. And if you had done this by, say, elimination, let's see, let me see if I can set this up. It would have been like y minus 2x equals 1, and then half of 4. Okay, so y minus 2x equals 1. You can see here everything's the same, so when you change the signs of these, everything cancels out. And that would be another reason why it's infinite solutions. All I did there was move the x's over to the other side and kind of simplify that answer. Okay, the next one, let's see. Here you got, say, something there. You do elimination, so you're going to change the sign. That would give you, say, x minus y equals 1, negative x plus y equals 2. The x's and y's cancel, but not the numbers. So that's considered no solution because 0 cannot equal 3. So that is what is called an inconsistent system. This is something that you might want to make sure, I mean, it might only be one problem on the test or something, or two, but you might want to make sure you have like this, like maybe on a note card or something prepared for that. Here's another example, very simple elimination problem. We can get rid of the x's, add the y's, add the answers, divide, and we get y is equal to 14. Solve for x, you're going to get x is equal to 17. So since you're getting an x and y answer, this would be considered one that has one solution, and what we call those are consistent independent systems. When you can get that one x and y answer, this is considered a consistent independent system. Okay, so now you kind of get an idea of how to classify. We'll get some practice with that later. Let's talk about reasonableness of a solution. Okay, here is an example. I'm going through it kind of quick. I'm fast forwarding a little bit, and we'll see where I end up at. 384 miles. Okay, so Tyre and Charmian, whatever, are training for a bike race. Tyre has logged 256 miles so far and rides 48 miles per week. Charmian has logged 125 miles so far and 48 miles per week. Is it reasonable to say that in 8 weeks they will have both logged a total of 384 miles? Okay, here you go, and if you did 8 times 48, you would get 384. So they will have both gone or ridden 384 miles, but let's look at the totals. They begin One begins at 256, one begins at 125. So, in all honesty, they're going the same amount every week, but Tyra started earlier. So there's never going to be a time when they've logged in the same amount of miles total. Because again, this is a total. So the answer to this really is no. It's not reasonable to say that in 8 weeks they will have both have logged 384 miles, because reality is that 384 is how much they have logged since the beginning. But really, for Tyra, it was the 256 plus the 384. And for Charmian, it was the 125 plus the 384. So you can still see here that Tyra has got more miles and will always have more miles. So it's not reasonable to say that they both logged in 384 miles. We're going to do some lessons with that where you have to kind of justify the answers or give me reasonings why that's reasonable or not. And I want you all to start kind of thinking how to write that in complete sentences, because that will help you with some questions on the test. And again, the reason why we're asking some of these questions is, keep in mind, this is stuff that you will see on the end of course exam. You've got to make sure you practice, and if you do have questions, feel free to ask. All right, that's it for today. Thank you very much, and hopefully I'll see these notes the next day.